Section 3.3, video number 2. The next type of statements actually occur in pairs. Logically equivalent statements are two statements whose truth values are always the same. The opposite of that are called negations, two statements whose truth values are always opposite. Now be careful. The word negation, singular, refers to the connective that looks like that and changes the truth value of a statement. But as a pair of statements, negations are two statements whose truth values are always opposite. So when you see a question that asks, are these logically equivalent negations or neither, you're basically being asked, make a truth table for both and compare their columns, their last columns. If the last columns are the same, the statements are logically equivalent. If the last columns are opposite, then the statements are negations. For example, let's use the statement that we ended the last video with. Negation Q pointing to negation P, and, by the way, did you answer the question from the last video? When we had the truth table for this, I'm not going to replicate all of it. I'll just bring back its last column. True, 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 false, false, true, false, false. The last column for the truth table for negation Q pointing to negation P was true, false, true, true. But where have we seen that before? Where have we seen the truth table where the only time it was false is when we had T and F? And the answer is conditional. Are negation Q pointing to negation P and P pointing to Q logically equivalent? I can spell negations or neither. This is going to be easy to answer because we've already created the truth table for the first statement at the end of the previous video. And the truth table for the second statement is one of your basic truth tables that you need to have memorized, either by remembering all the T's and F's or remembering the rule. The rule for conditional is it's false only when T points to F, and that's in the second row. The other rows are true. So the work is already done for this problem. We just have to compare the last two columns. If the last two columns are the same, the statements are logically equivalent. The last two columns are the same. Therefore, the statements are logically equivalent. I can't remember if I've shown you all this symbol yet, the three-dot triangle. It is a symbol for the word therefore. It will make its official debut in section 3.4, but it basically means you're about to draw a conclusion or answer a question. Therefore, the statements are logically equivalent. Excuse me. I don't think it's necessary to do an example where the statements end up being negations, but I'll just ask you real quick. In order to say negations, do you know what this column would have had to have been compared to the first one? In other words, let's pretend that we had something here and we did its truth table. We don't know what's there, but there was something there. And at the end, we said, therefore, negations. What would that column have to be the negation of that statement? Well, negations are two statements whose truth values are always opposite. So if they're always opposite, and this first one is true, false, true, true, then the negations last column would have to be false, true, false, false. So if they're completely opposite, the statements are negations. If they're exactly the same, the statements are logically equivalent. It doesn't have to be either one of them. For example, if this were true, true, false, false, then it's neither. They're not the same, and they're not opposites either. So logically equivalent statements and negations are both just a matter of two truth tables and comparing the last columns. If they match, logically equivalent. If they are completely opposite, negations. Otherwise, neither.